Let us look at the next section, students. This section contains 2 paragraphs. Each paragraph has 3 questions each. Each question has 4 options, out of which only one single option is correct. So let's start with the paragraph given for question number 26, 27 and 28. It says, before the X-ray diffraction technique was developed, the absolute configuration of chiral molecules were unknown. Amusingly, the first assignment of a 3-dimensional structure to a chiral molecule was a guess made more than a century ago by the sugar chemist Emil Fischer. He did so to simplify the depiction of the complicated stereochemical relationships of grape sugar, which is also glucose, to the other sugars. His choice by chemical correlation assigned the naturally occurring dextrorotatory optical isomer of 2,3-dihydroxypropanol, which is glyceraldehyde, the 3-dimensional structure labeled as D-glyceraldehyde. However, not all dextrorotatory optical isomer are labeled as D. Okay, so we've been given the D-glyceraldehyde and the L-glyceraldehyde, and the specific rotations have been given to us. Okay, so question number 26, it says, identify the sugar which is D as well as R. So R is the absolute configuration. So if you look at the options very carefully, students, we can clearly see that these are all the different Fischer representations of glyceraldehyde. So if we talk about the D or the R glyceraldehyde, students, we can first convert this into the Fischer form, and then we can figure out which of these compounds or which of these representations match with the actual D-glyceraldehyde. So if we try and draw the Fischer representation of this D-glyceraldehyde which is given to us, students, if we assume that the CH bond and the CHO group to be going away from us inside the plane of paper, so OH will be coming towards us from the right and MEOH will be coming towards us from the left. So we are to view along this line. So these groups have to go below the plane and this will have to come towards us. So if we try and draw the Fischer projection, so at this position we are going to have H. If we talk about CHO, so CHO will appear over here. And if we talk about the right hand position will be occupied by OH. And if we talk about the left hand position, it will be occupied by CH2OH. So this is the D-glyceraldehyde, students. Now all that is left is to compare the other representations to this given representation. So we can use the method of switches, or you can use the RS method, whichever way you're comfortable. So here we'll be dealing with the RNS configuration, students. So if we talk about the first compound contains the 4th prior group away from us. Okay, let us start and assign the priority. So OH will be 1, CHO will be 2, and CH2OH will be 3. Okay, so this is anti-clockwise and the least prior group is already away from us. So this is going to be S. If we talk about the second option now, we can assign the priority. The 4th is H. It is coming towards us. So we have to take note of that. So let us assign the priority. OH will be 1, CHO will be 2 and CH2OH will be 3. So it appears as if it is a clockwise rotation. But if we talk about the least prior group, it is coming towards us. So it appears R, but it will be S again. If we talk about the third one now, so in the third one also our task is easy. The 4th prior group or the least prior group is away from us. So OH will be 1, CHO will be 2 and CH2OH will be 3. So here we have an anti-clockwise rotation. So anti-clockwise rotation leads to the S configuration as the least prior group is already away from us. Okay, so the correct option obviously has to be the D option. We can start assigning the priority. So H is 4, OH is 1, CHO is 2, CH2OH is 3. So on moving from 1 to 2 to 3, it appears as if we are moving in an anti-clockwise fashion, but the least prior group is coming towards us. So this is the R configuration. Okay, so students, the D configuration is also the R configuration. We could also check for that in the base compound which is given to us. So it was 4, OH is 1, CHO is 2 and CH2OH is 3. So if we talk about the RS configuration at this chiral carbon, it is also going to be R. Okay, so students, for question number 26, we have to mark the correct answer as option D. Let us look at the next question now. Question number 27. Identify the correct statement. So option A, it says levorotatory isomer of glucose is D. So this is not correct, students. D-glucose is dextro. Okay. If we talk about option B now, the label D does not refer to the sign of optical rotation of plane polarized light, but to the spatial arrangement of the substituent groups. So this is a correct statement, student. It is also given to us in the comprehension that not all dextrorotatory optical isomers are labeled as D. So it must mean that it is referring to the spatial arrangement of the substituent groups. Okay, let's look at the C option now. D and L convention is used only for sugars. This is not correct, students. This is used for amino acids as well. Okay, if we talk about the fourth option now, dextrorotatory isomer of fructose is D. So this is also not correct, students. D fructose is levorotatory. So we know this fact, as sucrose is also called as inversion sugar. So sucrose is dextrorotatory, but when it is hydrolyzed to the formation of fructose, it has a levorotatory nature. Okay. So out of the given statement, student, only the statement given in option B is correct. So for question number 27, we have to mark the answer as B. Let us look at the next question now. Question number 28. When the following alkene undergoes reductive ozonolysis, it gives two different carbonyl products. So we have to find the D and L configuration for C star and C hash respectively. Okay. So when this compound undergoes ozonolysis, students, this bond will be cleaved and we're going to get an aldehyde on the left and a ketone on the right. So if we talk about the product containing C star, we're going to have the structure. And if we talk about the compound from the right hand side of the alkene, which contains C hash, so it is going to be the structure. Okay, so this is C star and this is the C hash. So if we try and convert them into the Fisher representation, students, we're going to have to look from this direction again, as we're done in the first case. So H will occupy the top position, whereas OMA will occupy the bottom position. So CHO will be towards the right and CH3 will be towards the left. So CHO will come towards us on the right and CH3 will come towards us on the left. So this is C star. So if we try and figure out the RS configuration, we knew that D was R. So if we try and assign the priority, students, OME will be first, CHO will be second, and the CH3 will be the third. So if we move from 1 to 2 to 3, the least prior group is already going away from us. So this appears to be anti-clockwise rotation. So this is S, students. So S means it is L. If we talk about the compound on the right, which contains C hash, so we can view along this line. So H will be at the top and OME will be at the bottom, students. So we can have H here and OME at the bottom. So if we look at the other two groups which are present, we have the CH3 towards the right and we have the COCH3 towards the left if we are viewing along this line along the plane of paper. Okay. So if we assign priority now, students, this is 1, this is 2 and this is 3. So this is a clockwise rotation and the least prior group is already away from us. So this is R and we know that R was D. Okay. So if we talk about the configurations for C star and C hash, so C star came out to be L and C hash, it came out to be D. So if you look at the options which are given to us, students, we can clearly see that the A option has to be marked as the answer for this question. Let us look at the next comprehension, students. Let us look at the comprehension given for question number 29, 30 and 31, students. So it says toluene reacts with a nitrating mixture to yield a mixture of isomers of B dash. From this mixture, the para compound is separated. Okay. So the para compound is labeled as B. Okay. So we can first start with the para compound itself. Okay. So this is the compound B, students. Half of the amount of B reacts with equivalent amount of sulfuryl chloride and a small amount of a radical initiator to give the compound C. So this react with one equivalent of sulfuryl chloride, which is SO2Cl2. So one of these hydrogen will be replaced and we're going to have CH2Cl and there will be a para NO2. So this is the compound C. Now this compound C is transformed with triphenylphosphine to give the phosphonium salt D. So when this reacts with PPH3, it gives us the phosphonium salt. So we're going to have the formation of this compound. So this is the compound labeled as D. So it is further mentioned to us that D reacts with the N-butyl lithium to give a Vilide E. Okay, so it reacts with N-butyl lithium, NBULI, so which is a strong base. Strong base is going to extract this hydrogen of the CH2 group present. So this is going to lead to the formation of the elide. So we're going to have the formation of para NO2 CH double bond P PH3. Okay, so this is the elide which is mentioned. This is E. Now students, it is further given to us that the second half of the B is converted with 2 equivalents of sulfuryl chloride. Okay, so we can start with the second half. It is allowed to react with 2 equivalent students. So we can have the formation of this compound CHCl2 NO2. So this is with 2 equivalents of sulfuryl chloride. Okay, so this is the compound which is labeled as F, students. Okay, so F is allowed to undergo basic hydrolysis to give the compound G. So when this is allowed to undergo basic hydrolysis, students, the compound G which will be formed will be CHO para NO2 in the benzene ring. Okay, so this is the compound G which is formed. So it is mentioned to us that G can be oxidized with the Tollens reagent. So if you look at the question number 29, students, the product obtained after the reaction of G with Tollens reagent is. So when this compound is allowed to react with Tollens reagent, students, this will undergo oxidation to give us the carboxylate anion. So there will be COO negative and there will be para-nitro group. Okay, so this is the compound which is formed in question number 29. Okay, so for question number 29 we have to mark the answer as B. Okay, let's look at the next question now. So in question number 30, the examiner seems to be interested in the product H. Okay, if we talk about the product H, students, so it was mentioned that E and G, they react to give H. So we can have the structure of E and G, students. We had found out that G was para-nitrobenzaldehyde, and if we talk about E, students, E was the Vilide or the elide. So when this two undergo reaction, students, they combine to give us this compound, students. So this is the product H which is required. Okay, so if you look at the options which are given to us, students, we can clearly see that for question number 30 we have to mark the correct answer as option A. Okay, we can now look at the next question, students. In question number 31, the examiner seems to be interested in the compound I. So first we have to figure out what the compound I is, students. So we had figured out H, which was a cis alkene. Okay, now it is mentioned that H on reaction with FeHCl followed by diazotization gives an intermediate which on further reaction with CuHCl gives compound I. Okay, so if we talk about the further reaction, students, we had figured out what H was. So H was this compound. Okay, now this is allowed to react with FeHCl. So this nitro groups will be converted into amino groups. Okay, so we have the formation of this compound. So it reacts with NaNO2 HCl and then with CuCl HCl. Okay, so the final product which will be formed is this. So the NO2 will be converted into NH2, NH2 will be converted into N2 plus, and then the N2 will leave and Cl will be substituted in the benzene ring. Okay, so this is the compound I which is formed. So in the question it is mentioned that the compound I is treated with Mg in ether, and then when it is reacted with excess of HCHO, the product obtained is. Okay, so first this will be converted into the Grignard reagent. There will be carbon ion generated at this position, students, and then those carbon ions will attack the HCHO molecules and convert into the CH2OH groups. Okay, so this on reaction with Mg in ether followed by reaction with HCHO, this will be converted into the alcohol. Okay. So if you look at the options which are given to us, students, we can clearly see that for this question we have to mark the correct answer as option B. Okay, both the CH2OH have to be at the para position.